Hey grade 11s, today's lesson is on line graphs. A line graph is typically used to show how a quantity changes over time. And we're taking a look here at the average monthly temperature in Vancouver. So we've got average temperature on the vertical axis, and we have the months on the horizontal axis. And we can see starting in January, the temperature dips a little bit, and then it gradually increases, tapers off a bit. Hits the highest average of the year, and it starts to decrease a bit, decrease a little bit more rapidly, and then level off in December. So we can see in the graph that the temperature increases from February to August. After August, the temperature comes back down until December. The first question is, how many months is the average temperature above 10 Celsius? So, where is 10 Celsius on our graph? It's right here. So, what I would suggest doing is drawing a line, and that line should be at 10 degrees Celsius. So I would suggest drawing a line like this, and then counting the months that have a temperature above that line. Not on that line, but above that line. So for example, April is right on the line, so that won't work. We have May, June, July, August, September, and October's just above it. So if we count those up, we see that there's 1, 2, 3, 4, 5, 6 whole months. 6 whole months, the temperature is above 10 degrees Celsius. And if we want to be specific, it goes from May until October. The advantage of displaying this temperature data in a line graph is it's going to be easier to detect trends in the data and also to obtain or get information from the graph. That's the big advantage of using a line graph. Okay? Great. So let's do an example together. Zachary helps his friend mail out sports clothing to customers in Winnipeg. They record the weight of the package and the cost to ship. So we have weight and cost. Draw a line graph for this data. Okay, so we have to think to ourselves, okay, how big does the weight get? The weight gets up to 10, and we certainly have more than 10 grid squares. How many do we have? I'm thinking we probably have 20, but let's see. 5, 6, 7, 8, 9, 10, yeah, 20. So every grid square could be half a kilogram. So we could go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the weight in kilograms. The cost goes up to 20 grid squares. Seems pretty straightforward. Every grid square will be worth 1. I'm not going to label all of them here. Well, let's say we'll label every 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 20. And that is the cost in dollars. So now what we'll do is we'll go ahead and we will plot the points So we have half a kilogram is $6. That's right here. 1 kilogram is $7. 1.5 is also 7. 2 is 10. 2.5 is also 10. 3 is 12. 4 is still 12. 6 is 15. 8 is 18. And 10 is 20. So we have a whole bunch of dots here. And now with that, we can go ahead and create our line graph. You should use a ruler to make your line graph, just to make it look nice. Connect each of those dots until you get something that looks like this. There is your line graph. This line needs to be just extended a wee bit. There we go. And this one also. Okay, there's our line graph. Okay. By interpolation, what would the cost of mailing a 5 kilogram package? So the first thing is what we're going to do is we're going to find 5 kilograms. And then what we're going to do is we're going to go up from that point. See where we touch here. And where we touch is just under $14. So maybe $13.80, something like that. That would probably be a good estimate. It is an estimate. The thing that is very clear when we look at this is that this is 13 and this is 14. So it's most of the way from 13 to 14. So probably, like I said, about 0.8. Now, if you told me 0.75, I would easily get on that too. 0.75 or 0.8 would both be great estimates. That's probably the best estimate we can make. So, go back down here. $13.80. Extrapolate the cost of mailing a 12 kilogram package. Extrapolate the cost of a 12 kilogram package. Well, what do we see here? We can see from this last bit of the graph the weight goes up 2 kilograms and the cost goes up $2. In other words, every kilogram gives you an extra $1. So, if we add 2 kilograms, we should be adding $2. And if this number here is 20 and we add $2 to it, an estimate for how much it should be would be about $22. Now, when we extrapolate that, we are assuming things. And when we are assuming things, sometimes we can put ourselves in a situation where we're getting a wrong answer. So that's why we have to be careful when we assume things, but we have no other information to base this answer off of. We saw that the last bit of the graph increased at a rate of $1 for every additional kilogram. So if we go up 2 kilograms, price is going to go up $2 seems to be a reasonable way of calculating the cost of mailing a 12 kilogram package. But it's not as simple as interpolation. Interpolation is you're actually reading between values, so it's super easy. All we have to do is draw a line on the graph, and we're able to figure out what the value is for that. Try some questions, and make sure to ask for help if you need it.